morning children, and we are continuing with our online classes. Today is going to be more of an explanatory class. You need to understand the explanation that I am going to give you right now. We've done this already in class 5 and you are well aware of it, of the two methods that I have already taught you. But nevertheless, we'll run through it again, and now you will have to really be a little bit more careful, because in class 5 the numbers were much smaller. Now the numbers become bigger. Now, before I go into the methods of finding the HCF, we are only targeting HCF, which is called highest common factor. That means I have to find the factors of two or more than two numbers, and then find what is the common factors between them, and the highest one amongst all those common factors becomes the highest common factor. Now, there are various methods of doing it, but we are only going to learn two methods for both HCF and LCF. Again, a suggestion, please do put on earphones or headphones so that you can only hear me and have your undivided attention towards what I am saying. Because maths is something that you really have to understand the concept in order to understand how the sums are going to be done. Now we are targeting highest common factor, and we are going to look at the two methods that we are used to, and we only learn these two methods. Now there are methods like common factor method, where you have to find all the common factors. That's a very tedious task and it takes a lot of time. Then we have the prime factorization method that I am going to teach you. Then you have the factor tree method, where you get all the factors making like a tree. I'm not teaching you that. That doesn't have to be done. Long division method, that also I'm not going to teach you, because that again is a difficult method. As long as you know a method of finding the highest common factor, you don't have to know all 5 or all 10 or all 15 or all 20. There are no so many methods. There are only about 4. Then we come to the short division method. That I'm going to teach you. So we are going to do prime factorization method and short division method. These are the only two methods that I'm going to teach you. These are the only two methods by which you will find the HCF, and these are the only two methods by which I will ask you to find the highest common factor in the examination. Now before we move on to the prime factorization method, let's understand what it means. Prime factorization method. Prime means I am going to use only and only and only prime numbers. Factorization means I have to find the factors that are prime numbers, and the method I am going to show you. Now let's run through what are my prime numbers. 1 is not a prime number, so I have 2, I have 3, I have 5, and I have 7. Till 10 there are only 4 prime numbers. Till 10, that is 2, 3, 5 and 7. 1 is not a prime number. 1 is a unique number. It's neither composite nor prime. Now I have to ask myself, what numbers are divisible by 2? All even numbers are divisible by 2. That means it should be ending with 0, with 2, with 4, with 6 and with 8. So all even numbers. Now I ask myself, if I say my 3 times table, what numbers do I get? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, 3 six are 18. Now if you look at these numbers, 1 is odd, 1 is even, 1 is odd, 1 is even, 1 is odd, 1 is even. So 3 has odd numbers also and even numbers also. So I have to check whether it's an odd number or an even number. I will have to check whether it is divisible by 3. And which numbers are divisible by 3? When you add up the digits, and the sum that you get is a multiple of 3, or it can be divided by 3. Now I look at 5 times table. 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25, 5 six are 30. So all the numbers of 5 times table are either ending with 0 or they are ending with 5. So all numbers ending with 0 or 5 will be divisible by 5. Let's come to 7 times table. Now there's no test of divisibility for 7, but there is a method by which you can find out whether it's divisible by 7 or not, and that is, if I say 7 times table, again I have 7 1s are 7, 7 2s are 14, 7 3s are 21, 7 4s are 28, 7 5s are 35, 7 6 are 42. So you're again watching, after 7 1s are 7, 7 2s are 14, it goes into 2 digits. So all the numbers again in 7 are either odd or either even. Every other number is odd and even. So 7 also has odd or even. So a number may be divisible, that is divisible by 2 can also be divisible by 3. It can be also divisible by 7. Because all even numbers are either divisible by 2 or 3 or 7. So I have to check for all of them. Now coming, see, when you get the numbers, when we are looking at the numbers will either be odd or the numbers will be even. So till 7 you should be clear with your test of divisibility of prime numbers. So any even number that I get will be either divisible by 2 or 3 or 7 in prime factorization. When I look at odd is only for 3, 5 and 7. Now why do I say 5? Oh yes, even numbers I will have all 4 of them, because 0 is also divisible by 2. Any number ending with 0 will be divisible by 2. So a number like 70 will be divisible by 2, will be divisible by 5, will be divisible by 7 also. So all even numbers can be checked for 2, 3, 5 and 7. Odd numbers. Now all odd numbers ending with 5, only they will be divisible by 5. Odd numbers can be divisible also by 3, can be divisible by 7 also. But odd numbers cannot be divisible by 2. So once you get this concept that I have 2, 3, 5 and 7, and you know what all numbers can be divisible. All even numbers 2. They can also be divisible by 3. If they are ending with 0, they will be divisible by 5. And they can also be divisible by 7. But odd numbers can be divisible by 3. They can be divisible by 5 if they are ending with 5. And they can also be divisible by 7. But they will not be divisible by 2. Now let's look at an example. I am showing you the prime factorization method. Let's take 3 numbers, 12, 24 and 48. What I need to do out here is, I need to take all these numbers separately and factorize them using short division method. That short division method is the next method, but using the method of short division, I will factorize these numbers or divide these numbers starting with my prime numbers. So I write 12 and I draw a line like this. You all have done it already. I have explained it to you in class 5. So now I ask myself, what's my first prime number? 2. Does 2 divide 12? Yes. 2 6 are 12. Again I ask myself, does 2 divide 6? Yes. 2 3s are 6. When it cannot be divided anymore by 2, then I go to my next prime number. Now 3 cannot be divided by 2. But what is my next prime number? 3. Does 3 divide 3? Yes. 3 1s are 3. And it is got factorized till you get number 1. Over. Let's take the next number, 24. Starting with the first prime number. 24 divides by 2? Yes, it divides by 2. 2 12s. 12 divides by 2? Yes. 2 6. 6 divides by 2? Yes. 2 3s. And I go on asking myself till I cannot divide any more by that particular prime number. I don't jump. If I've got 12 here, I don't start dividing by 3 because 3 4s are 12. No. You go on with that prime number till that prime number cannot divide the number anymore. Now 2 cannot divide 3. So I stop with 2 and I go to my next prime number, that is 3. 3 divides 3. 3 1s are 3. It's over. It's factorized. Now I take my next number, number 48. And again I start dividing and asking myself, does 48 divide by my first prime number? Yes, 224. Again by 2, 2 12s are. Again by 2, 2 6 are. Again by 2, 2 3s are. I go on dividing till I cannot divide by that prime number anymore. So after 2 3s are 6, now I cannot use 2 because now 2 cannot divide 3. It is then I stop. You go on with a prime number till it cannot divide that particular anymore. Just because I got 24, I don't divide it by 3 8s are 24. Just because I got 24, that doesn't mean I divide 4 6 are 24. You can't divide by 4 6 are 24 because 4 is not a prime number. We are doing prime factorization method. That means I can only use prime numbers, no other number. I cannot use 4, I cannot use 6, I cannot use 8. So, next prime number 3, 3 ones are 3. Now what do? I write their factorization like this. 12 is equal to 2 into 2 into 3. 24 is equal to 2 into 2 into 2 into 3. 48 is equal to 2 into 2 into 2 into 2 into 3. Now I will circle the numbers that are common to all 3 numbers. So 2 is here, there's 1 2 here, there's 1 2 here, and there's 1 2 here. Again 2 is there, 2 2 2. There's 2 and 2 here, but no 2 here. So I cannot circle these 2. There should be all common in all the 3 numbers. Now next number which is common is 3 3 3. And there I get my common numbers for all 3 numbers, and then I write them together. HCF is equal to only taking the common numbers once. One set of 2, 2 into another set of 2 into 2, and one set of 3, only 3. So each set has to be taken only once. Remember children, each set, 2 is common here, 2 is common here, 2 is common here, 1 2. 2 is common here, 2 is common here, 2 is common here, another 2. 3 is common here, 3 is common here, 3 is common here, 1 3. So only one set has to be written only once. So now what's my answer? 2 2s are 4 and 4 3s are 12. And I have found the HCF, that is the highest common factor of the numbers 12, 24 and 48. This is the prime factorization method. The next video I will show you the short division.